Hi, it's Miss Hamiter, and our school library committee has met, and we have a programming idea to run by you today. Technology is developing day by day, and innovations are quickly becoming a natural part of life. Children now need to be creative people who produce innovation rather than just consuming digital content that is offered to them. This is the crux of our programming idea. We would like to use Bloxels as a video game design option for this year. It would be a year long program. The fifth grade students would be targeted. They would be able to do this on their PLC Fridays and on the drop in library times when there aren't classes visiting. What is Bloxels? It's an online gaming platform where students as young as 8 are able to create their own video games. It begins with a hands on, concrete idea of using blocks to build. They then scan that creation using an iPad and transport it into the virtual world where they can still create and add things, add pitfalls and all kinds of things that you would find in a normal video game. What are the benefits of this program? Well, they're using their traditional literacies of reading and writing narratives into their games. They're also using those digital literacies and learning how to navigate in that world. They're using their 21st century skills, the four C's: communication, collaboration, critical thinking, and creativity. Bloxels actually offers each class its own library to collaborate with. So students can create something and then they can put it in the library if they would like to share it with other students. So that way they're not having to access outside people. It's at the very top of Bloom's taxonomy because it's creating from scratch, from the ground up. Um, and then it also includes all of the AASL shared foundations and domains. It is all there for them. One of the good things about this is no coding is required. At the same time, this is still allowing them to use those logical steps and reasoning that they're going to need for coding in a later grade level. They still have to know things about the logical order of things, if then statements, true false statements. They're still going to learn lots of things that are going to take them into coding. Another benefit is that they can use their video game to demonstrate interdisciplinary knowledge. So here's an example of a student who used the video game to show his knowledge in a history class. In the middle, there's one where a student built a space world and then went through all the planets and were able to show what they know about the planets. And then finally, the one on the bottom was a math quiz that someone created using true false options. So if they get it right, they get to continue on. If they get it wrong, it's false and they fall down the hole and have to start over again. Our objective with this programming idea is that by the end of the year, students will create and publish a completed video game to the online arcade that demonstrates a concept from the fifth grade science curriculum. So we are looking to add that interdisciplinary knowledge. Our timeline would be scaffolded. During the first and second quarter, students would first play some other games that students have created, and then they would learn how to create video games on their own in Bloxels using a guided inquiry approach. They would do that during their library time. During the third and fourth quarter, then, that's when we would start planning with their science teacher. We chose science because it is a star tested subject. And at this point in time, they are going to be ramping up and doing a lot of review. And so we thought this was a great way for students to review. They would plan with their teacher in their science class, and they would come to the library with their plan and create their science video game in the library section. By the end of the fourth quarter, we hope to have a Bloxicon day, kind of like Comic Con, but Bloxicon, where we envision the library being set up with multiple large screens and game console controllers, where students could then come in and play their game on a big screen that day. How will our program be assessed? Well, each of the projects will be graded using a rubric. So the committee will review that rubric data at the end of everything. They will look for like the number of completed projects, the number of passing grades, And other data to be considered: number of students who visit the library to work on their project outside of their normal class time, or the number of participants on the Bloxicon day. We might even have things like the most played program, or some other little contests going on during that Bloxicon day that we could gather some data from as well. What is the cost? I know you're anxiously awaiting that information. We already own the physical blocks and the mats. They are located, they're in the closet when I arrived to this job. They have never been opened as far as I can tell. We already have Chromebooks and iPads, and so the only thing we are missing to make this happen is the online subscription to Bloxels, and it is about $7.14 per student at 175 students, for a total of $1,250 for the entire year for the entire fourth grade. Well, this is backed by research as well. Hung and some of his research buddies looked at 30 different studies from 2010 to 2020 dealing with video game design. They coded those studies for different types of literacies, for ages and grade levels, monodisciplinary versus interdisciplinary, and what type of game tools were used. They found a couple of things that I thought were relevant to our programming idea. So, the most common way that people used video game design, was for teaching computer science. And only one third of those used interdisciplinary subjects. So, we're looking at a 10-year period here. So, that did sort of change over time. But they did note educators need to be aware of the interdisciplinary learning potential of the game making approach and seek to embed it into a wider curriculum beyond the core discipline of computer science. And so that's what we are seeking to do here. Our students will be adding the academic content from their science class to the creative game design as well. They did find over time this approach is reaching out to younger populations. They felt it was more suitable for secondary students because they have already mastered foundational literacy skills. But most of those people, like I said, were working with computer science, and so they were coding. And so Hung did note, when working with younger learners, teachers may consider simplifying the technology component in game design to lessen students' cognitive load. This is exactly what Bloxels has done for us. They've removed the coding component. We're still creating, still needing those thought processes that are going to be needed in coding later, but taking that out of the equation so that students are able to put in their skills. Will our special pops be able to participate? Well, according to Meisher, Tall, and Kessler, yes, they will. They looked at fourth grade students who had learning difficulties, and they took them through a game design project. They scaffolded their approach. First, they played the games, then, they learned how to make the games, and then they added their academic content to the games. They removed the coding, they used game generators so that they took that cognitive load away from them. But they did find an analysis of teacher documentation indicates the student skills were enhanced in three main aspects: cognitive, emotional, and behavioral. They found that not only were the students growing in their knowledge, but also they had higher self esteem. They had better behavior when they came into class. They found that their games changed from the beginning to the end of the project, with much more complex projects toward the end of the project. My timeline that I have set out calls for the same scaffolded approach, which is why I think we can be successful. That, along with the collaboration that we're going to have, I think that our special pops will definitely be able to participate here. The biggest finding, I think, for me was from Bullitt and his researchers. They looked at fifth and sixth grade students, and they actually scaffolded video game design using Pixel Floors. Pixel Floors was the precursor to Bloxel, so it's the same company. That was just an earlier version of what is available now, which is good for us. They gave a pre and a post test on the Torrance test of creative thinking, and the results were pretty good. The students made a statistically significant improvement in all subdimensions of the TCTT scale. Their fluency, their ability to produce a lot of ideas, their flexibility to bring different ideas, their originality and elaboration, all of those things improved. So, in conclusion, why should we spend a year and $1,250? Well, for our students will be producers instead of consumers of digital content. Using a scaffolded approach to design, creativity is going to increase. Cognitive, emotional, and behavioral skills will improve. I see all of these things improving and improving across the board, not just in the library, but also in their classes, because the creativity is definitely going to manifest itself in other areas of their lives. It's also, students will develop logical thinking and other digital literacy skills while showing what they know in their current science curriculum, getting them ready for their science STAR test. So here are some references that I have if you want to check these out a little later. But thank you so very much for your time. I know that you're a very busy person. We hope that you will consider our programming idea of video game design for next year in the library.